Welcome to the third lecture in Growth and Motor Behavior, and today we're going to cover the theoretical perspectives in motor development. We're going to go over three main theories. We're going to go over the maturational perspective, the information processing perspective, and the ecological perspective, which can be broken down into the dynamical systems approach and into the perception action approach. Starting off, we're going to talk about the maturational perspective, which emerged around 1930s. And this perspective attributes the changes in development to the changes in maturation that take place across the lifespan. So as a result, development results from inherited factors, and we're genetically programmed to display a series of predetermined behavior patterns. This perspective also says that the environment and experience play a limited role in influencing our motor behavior. So the researchers here, they cataloged the age differences in structure and function and assumed that these changes mirrored the changes that take place in the brain and central nervous system as we age. Thus, development is a process controlled by internal or genetic factors rather than external factors. If we're going to explain development, we can say that the emergence of complex behaviors is due to the maturation of the higher brain centers. For example, the emergence of walking is due to the maturation of the central nervous system. And some behaviors emerge due to the maturation of inhibitory processes, meaning when walking emerges, that's because the crawling behaviors have been now inhibited by the central nervous system. Based on this perspective, you can't teach new skills until a child has matured to the appropriate level because their central nervous system cannot handle the new motor skills that you're trying to teach. Thus, you cannot accelerate development beyond a certain point as well. As a result, development is now stage-like or discontinuous, meaning that certain behaviors will be displayed at certain times, and only at those times, rather than creating a more gradual process of development. A lot of the research that was done was conducted through normative assessments. So basically, researchers assess the average performance of children to develop age-dependent norms. So, for example, at 3 months old, the baby will begin to reach. At close to 1 year old, they will begin to start to walk. Most of this data was collected in the 1950s, but it is still used today. This picture right here kind of shows us how maturation theorists would display and describe the motor sequence that takes place across the first year and a half of life. You start in the fetal position, chin up, chest up, and sit with support, so on and so forth. And you can see here that since these are age dependent, they believe that the central nervous system has developed enough at this point in age in order to allow for certain behaviors to be shown. So, research perspectives here. We say that the basic motor skills emerge automatically, and experience does not influence motor skills. And they also say that the nervous system development is the most important factor. There is also a focus on the maturation of skeletal and muscular systems, but the maturation of the nervous system from this perspective plays the biggest role in contributing to motor development. This differs from the information processing perspective, which emerged a little bit later on around the 1970s, and it grew out of information technology. And this is the idea that information and its use can be measured. And a lot of it, like I said, comes from a background in computer science. A lot of motor control and learning researchers use this perspective, and a lot of times it's also used in memory and cognitive research in psychology. So, Development from information processing system is viewed as changes in the ability to both perceive and process information, and evaluate the information in the environment and begin choosing the appropriate responses, making the entire process of development significantly more cognitive rather than based on the unfolding changes that take place according to the maturation perspective. And they view the changes in development as influenced by knowledge and experience. For example, if I'm a child learning how to walk, if I fail and I fall down, I'll cognitively process everything that took place around me and be able to make the appropriate changes so that I can maybe walk one step further the next time that I attempt the task. Based on this approach, you can teach children to focus on appropriate information in order to enhance learning and performance. And learning is enhanced by experience, as you are now able to become aware of the changes that need to take place in your motor behavior in order to learn to perform the task significantly better the next time. And this differs from the ecological perspective that says that development is driven by the interrelationship of the individual, environment, and the task itself. And the body systems self-organize, but it's not solely caused by the central nervous system. And again, we can break down the ecological perspective into the dynamical systems approach and the perception action approach. The dynamical systems approach says that many systems work together to influence the larger system. The systems of the body include nerves, hormones, skeletal systems, so on and so forth. But no one system is really in charge of driving development. We also say that motor skills are softly assembled, and individual environment and task constraints are constantly changing and interacting, making the process of learning new motor skills much more flexible and adaptable than the other two approaches. And the assumptions of the dynamical system perspective say that new behaviors emerge from the interaction between the individual, environment, and tasks. And this is saying that the behaviors are softly assembled rather than creating a strict hardwired plan. And behavior emerges or self-organizes from the interaction of constraints. When we're contrasting the dynamical systems and the maturation approach, we know that the maturationalists really focus on the central nervous system as the only system really relevant to development and serves as the only rate controller. However, the dynamical systems approach acknowledges that different systems may be rate controllers for different skills, and this concept accounts for the changes that occur across the lifespan. Even in aging, change does not occur in all systems at the same time. We'll pause the lecture here and we'll open up with the next lecture, with the next